Hello chemistry students, this is our last lesson for gas and atmospheric chemistry unit. Now we're going to start gas stoichiometry. Now this would have been very different in class, so instead I'm going to show you how to work through a gas stoichiometry problem because we have gone over stoichiometry and we also have gone over all of our gas laws and more important the ideal gas law, which is more relevant for this particular question, for gas stoichiometry questions. Okay, so here's a question, it's from page 603 in your textbook. It's question number 7. So let's start by looking at the question. It's the combustion of propane and oxygen. This looks like a complete combustion reaction, just CO2 and water. Now it's asking for the volume of carbon dioxide, so we're going to figure out what that is. Now you see volume is what it's asking for, so you're probably going to think, since this is a gas unit, we're going to use the PV equals nRT, or the ideal gas law, to figure that out. So we're just analyzing right now. We have pressure. Look, it's given to us there. Might as well write that down. So it's 202.1 kilopascals. Also take note the unit is correct, so we don't have to change that. We're given temperature as well. Look, temperature is 25 degrees Celsius, but it's not at the correct unit, so we do have to change that to Kelvin by adding 273. We get 298 Kelvin. Alright, so now we have temperature. We know what the gas constant is, 8.31 with its correct units. We need to figure out, we don't have volume, we have to figure out volume, right? That's what the question is asking us for. And we also need to figure out the number of moles of CO2. Okay, we don't have that. What we are given though is mass of propane. So let's write that down. Mass of C3H8 is 54.0 grams. All right, now to go from a measurement of propane to a measurement of CO2, we need moles. So we can go from moles of one to moles of the other. That's why this is a stoichiometry problem. We're going to go from a certain number of moles of propane to a certain number of moles of carbon dioxide. This exists in a 1:3 ratio. Okay, so in order to do that, we have to convert our mass of propane to moles of propane. We know that moles are equal to mass divided by molar mass. And looking at your periodic table, look, we need molar mass of propane to make this conversion. So let's write that down. Molar mass of propane is 44.1 grams per mole. Good, so now we have mass given to in the question and we have molar mass from a periodic table. We can divide the two to get the number of moles. So 44.1 grams per mole. And we get 1.224 moles of C3H8. Okay, so we now know the number of moles of propane, and we have to take that information and convert that to the number of moles of CO2, and we will do that using mole ratios. Let's use a fact table method setup that we seem to be comfortable with to do that now. So we have to determine the number of moles of CO2. We are given, or in this case, we have determined how many moles of propane we have, 1.224 moles of C3H8. Okay, now moles C3H8 goes at the bottom because we want to get rid of that unit. We want to keep moles of CO2 at the top. So mole of CO2 goes then at the top. Okay, now this is a mole ratio. So the coefficients associated with CO2 and propane are the ones we're going to want to look at. So we look at the question, the balance equation. CO2 has a coefficient of 3 and propane has a 1. So notice units cancel out, right? And we're left with 1.224 times 3, which is 3.67 moles of CO2. Okay. Now we have the number of moles now of CO2, going back to how we've analyzed this question. Now we have moles, and all we need to figure out is volume. So that's the next part. The last part of solving this question. We're going to use the ideal gas law. Let's just isolate for V now that we have N, and we get nRT divided by P, and we can plug things in. So number of moles we've determined of CO2 is given to us, or we can write it down here from our calculation, 8.3 0.31. This is your gas constant. Okay, times temperature, 298 Kelvin. We had to make that conversion at the beginning. Pressure is 202.1 right up here. We didn't have to convert anything. Those were the correct units. So now watch how mole cancels out, kilopascal cancels out, Kelvin cancels out, and we're left with then liters, the unit we want. We get 45.011. We're going to round that to the nearest number of sig figs, which in this question is 2, and we get 45 liters as our final answer. So there you go. This is how you do a gas stoichiometry question. Since we have gone over, spent a lot of time on stoichiometry, you know the ideal gas law. We're just bringing this all together. This is not entirely new. Hopefully this helps. Post any questions and I'll be sure to answer.